All right, one last free fall problem here. We're on a cliff, we're standing at the edge, and we drop a rock. And we know that this cliff is 200 meters above the ground, and we want to know how much time it's going to take for the rock to hit the ground. So what do we know? Well, we're dropping the rock, so we know its velocity is 0 because we're just releasing it. We're not throwing it. It's just being dropped. We're on Earth, so we can assume acceleration from gravity is 10 meters per second squared. I make it positive because the rock is only falling. It's just easier to have all positive numbers. And we know the rock is going to fall 200 meters, so I'm going to put 200 meters here. This is really all we know given in the information. We're given the height of the cliff, we're given that we dropped it, and we're given that we're on Earth. Nothing else is known at this point. So we're trying to find the time. We're solving for t. So what do? We look at our equations and we say, what can we do to figure this out? So this equation I can't really use yet because I don't know the change in velocity. This equation's no good. I can either use this equation or this equation. I could use this one to figure out the average velocity. Actually, no, I can't use this one either because I don't know the average velocity and I don't know the time. So this is really the only equation I can use. So I'm just going to plug into it, and we know everything but t. So let's just plug in. Delta x is 200. So I plug in 200 equals vi, 0, times t, plus 1/2, a we said was 10 t squared. So this is me plugging in, and I have everything but t. I'm going to try to solve for t. So 200 equals 0 times t is just 0, so that goes away. 1/2 times 10 is 5. So I get 200 equals 5t squared. So I just want to find out what t is. So I divide each side by 5. And when I do that, I get 40 equals t squared. So that's not t. I want to find out what t is, not just t squared. So in order to find out t, I'm going to take the square root of both sides, because taking the square root of t squared gives me t, and then you're going to have to use a calculator here. You'll take the square root of 40, and if you do that, you will get that t equals 6.32 seconds. And that's really all we're looking for, is the time it takes to hit the ground. Now, if you want to prove to yourself that this makes sense, we can find VF if we like. If something falls for 6.32 seconds accelerating at this, we can use this equation to find VF, but you might have figured out by now it's just going to be 63.2. That's going to be the speed that it hits the ground at. The average of 0 and 63.2 is just going to be 31.6. And if something, oh, that doesn't go there, it goes here, 31.6. So if you go an average of 31.6 meters per second for 6.32 seconds, that's going to give you 200 meters. So you can check and confirm that if you want. But the biggest thing on this one is just it's a little different than usual. You're not solving for delta x, you're solving for t. And this isn't too difficult to do if the initial velocity is 0. If you're throwing it, it's a lot trickier. It becomes a quadratic equation, which we'd prefer not to solve. So anyway, that is how you do a problem like this when you're asked to find out time. Set it up the same way, fill in what you know, and then this equation comes in handy. It's used a lot in these free fall problems, so don't forget you have it. Plug in and solve for whatever you're looking for. So until next time, I am Derek Genova. Have a delightful day.